Hello, my favorite pre-calculus people. This is Unit 6, Lesson 4. We're going to talk about parametric equations. Parametric equations is a pair of equations that always represents how an object is moving horizontally on a coordinate plane with relationship to some parameter. In this case, it is time. T for time, and how it is moving vertically up and down a coordinate plane. So what we're going to do in order to graph this pair of parametric equations is we're going to make a T-chart. For part A, we're told to graph using time where it's from -3 to 3. So in our T-chart, we're going to put our values from -3 all the way down to +3. And then what we're going to do is we're going to plug these values into these two equations, and that's going to give us our ordered pairs for x and y. So when I put -3 in the place of t right here, well, -3 squared is 9. 9 minus 2 is 7. A -2, that would be 4 minus 2, which is 2. A -1 would make that 1 minus 2, which is -1. 0 squared minus 2 is -2. We'll put this 1 right here. 1 minus 2 gives me -1. 2 squared is 4 minus 2 gives me 2 again. And then 3 squared is 9 minus 2 gives me 7 again. So those are my x coordinates that I'm going to graph. And then for my y's, I'm going to do the same thing, but I'm going to put them into this equation right here. So I am going to put -3 here. That's going to give me -9. Put a 2 here. That's going to give me 6. Put a -1 here. That's -3. A -2 here gives me -6. A -1 gives me -3 again. And then the 2 and the 7. Okay? So once I get my ordered pairs, then I just come over here and I plot them. So I'm going to plot 7, -9, and then 2, 6, and -1, -3, and -2, -6. That does not look right, does it? Was that one? Hold on. So I just decided to back up and start this over again, because as soon as I started to plot a point way over here, I was like, something's not right. And I realized what I was doing. I'm kind of glad I made that mistake so that you could be careful of it too. I found myself, when I put this -1 here and got -3, I came back to this -1 and started picking up this -2. I started picking up my x coordinate and plugging it into there. So I'm kind of glad I made that mistake, just to show you how easy that is. But you're actually going to plug in your t values into here and get your y values. So plugging in a 0 gives us a 0 there. Plugging in this -2 actually makes that a -6, so that's better. Now I'm going to plug in a 1, 2, 3 right here, and that's going to give me a 3, 6, 9. There we go. So everything's better now. Okay? So -2, 0, and -1, 3, and then 2, 6 I already have. I need to plot to -6, and then the 7, 9. There we go. Okay? And as long as your interval is continuous, okay, this is a continuous interval from -3 to +3, then you will connect your points with a smooth curve. Okay? We're going to pretend that's a smooth curve. I think it's supposed to be a sideways parabola, okay? As a matter of fact, I know it is. I'll show you why in just a second, okay? But if you're given just x values right here, these are called discrete values, meaning it's not continuous. you just have some x values as integers, then that is a discrete interval, then you will not connect all those points, okay? You would just leave it the way it was with just the points up there, and you would not actually draw the parabola, okay? All right, now let me show you why I know that this is a sideways parabola. Because we're going to do what's called eliminating the parameter. That means, remember, your parameter is time, that's t, so that means we're going to eliminate t out of this situation, and we're going to give the resulting rectangular equation. And a rectangular equation is nothing more than an equation that's only in terms of x and y. It's the same kind of equation that you've been graphing forever up until this point, okay? So the way that we eliminate the parameter, or the way that we eliminate t, time, okay, is we choose one of these equations and we solve it for t. And I always use the one that's the easiest. Well, I'm looking at this one and it's got a t squared. Well, that means I'm going to end up taking plus or minus the square root if I try to get t by itself. But here, t is to the first power. All I have to do is divide by 3 and boom, look at that. T is all by itself. That's your first step. Step 1. Pick one equation, and that right there means step 1. Pick one equation, solve it for t. Step 2, it's like solving a system almost. You're going to come back over here, and in the place of t, we are going to put y over 3. Step 2. So that's going to be x is equal to y over 3 squared minus 2. All right. Next thing we're going to do is we're going to simplify this equation, because this equation is now in terms of x and y only, no t, no parameter. The parameter is gone. We're just going to simplify it and make it a nice, pretty rectangular equation. All right. So I'm going to square both of these. It's going to give me y squared over 9 minus 2. I am going to clear out the fractions here by multiplying everything by 9, since that's my denominator. And then I'm going to get this set equal to 0 and put it in general form. So I'm going to subtract the y squared over. I'm going to add the 18 over. And that's going to leave me with 0 right there. So that is general form. General form is something we haven't talked about in a long time, actually since the very first unit when we did conic sections. Because this right here, the fact that y is squared and x is not, that tells me that this is a sideways parabola. That's the figure that it makes, is a sideways parabola. Okay? I know it opens to the right because my x is positive. Okay? All right, now, look at number 3. It says, find the rectangular ordered pair in the form of xy for this pair of parametric equations when t is 2. Well, that's really the same thing you were just doing a while ago when you made a table. It's just that with your table, you had a list of values. You had a whole bunch of values for t. Here, you're only going to have just one t value, but you do the same thing. You just put 2 in the place of t, and you simplify. So it's really not difficult. It's just a matter of knowing what to do. Okay, so your ordered pair is 6, 9. Okay, all right, last 2. Eliminate the parameter and identify the figure. Well, that's really what we just did in problem number 2. So we're going to start this out the same way. We are going to eliminate that parameter, okay, by solving one of these equations for t and then plugging it into the other one. I'm actually going to get rid of this one. I'm going to get rid of t in the y equation, because if I try to solve this one for t and then plug it into that one, I'm still going to have that square root to contend with along with a fraction, and I don't want to do that. So I'm going to solve this. I'm going to solve this one right here for t, and I'm going to start out simply by squaring both sides. And there you have it. Square root's gone. T is easy to solve for. All I have to do is subtract 4. Whoa. And t is by itself. Okay, there's your first step. Get t by itself. Okay, now we're going to plug that in right here. So that's going to give me x is equal to 3 times t, which is now y squared minus 4. Bring over that plus 2. And now do exactly what we did a while ago. Simplify that and get it in general form. That means get it set equal to 0 with no fractions and no decimals. Would y'all like me to sing you a song while I do this? Jingle bells, jingle all the way. Oh, what fun it is to parameter. Alright, okay, so here we go. So, no fractions, no decimals, everything's set equal to 0. And again, what we end up with is another right-handed parabola here. Okay, so a right parabola. This is going to open to the right. Okay, now they don't always turn out to be parabolas. Look at this one. Whoa, we got some trig in there. Everybody say, yay, we have trig. Okay, so this one's a little different because you'll notice that this time your parameter is not t. There's no t in here. There's a theta instead. Okay, so this time we are going to eliminate theta. Okay, so when there's trig involved, sine and cosine, you do it a little bit differently. You solve each one of the equations for sine and cosine. So I'm going to solve this first one for cosine theta. So I'm going to add 1, divide by 3. Cosine theta is x plus 1 over 3. Then I'm going to take my second equation and solve it for sine. So I'm going to subtract 4. And I'm going to divide by 2. I'll just sing math to you today. Okay. Then you take your handy dandy Pythagorean identity that says cosine squared theta plus sine squared theta is equal to 1. And you plug in x plus 1 over 3 in the place of cosine and y minus 4 over 2 in the place of sine. X plus 1 over 3 squared plus y minus 4 over 2 squared equals 1. So you can just leave this at first as x plus 1 quantity squared. Square this and you get 9. Leave this as y minus 4 quantity squared. Square this and you get 4 equals 1. And it's at this point that you can tell you have an ellipse. Okay? But let's put this in general form simply because you need to know how to do that. Okay? We're going to, well, I think, let me think. I think I'm going to get rid of these fractions. I'm going to multiply everything by 36. You know, there's more than one way to start, so I needed a little think time to figure out how I wanted to start it. Okay? So 9 divided into 36 is 4. 4 divided into 36 is 9. So this gives me 4 times the quantity of x plus 1 squared, and 9 times the quantity of y minus 4 squared. 36. Multiply this out. Let's expand it. X squared plus 2x plus 1. Do the same thing here. 9 times y squared minus 8y plus 16 equals 36. Distribute the 4, distribute the 9. 4x squared plus 8x plus 4 plus 9y squared minus 72y plus I-90 plus 54. Is that 144? Yep, it is. Get everything set equal to 0. So I'm going to combine some like terms. I'm going to put it in general form. All my squared terms comes first. This one and this one in alphabetical order. All my linear terms comes next in alphabetical order. And I am going to combine my like terms. That's 148. And then finally, to set it equal to 0, subtract. And so in general form, I get 4x squared plus 9y squared plus 8x minus 72y plus 112 is equal to 0. And that is an ellipse. Okay? Now, when you have the general form, if you've forgotten how you can look at it in general form and tell what your conic section is, look at here. I'm going to remind you, this is what you learned in that very first unit. General form, ax squared plus by squared plus cx plus dy plus e. Okay? If you have a parabola, then whatever the coefficients of x squared and y squared are, it will give you 0. What that means is there's either an x squared or a y squared. You know, because like you had, if you go back to number 4, I think it was 0x squared minus 3y squared plus x plus 10, because you didn't have a y either. Okay? So if you have a parabola, you have an x squared or a y squared. You don't have both. So that ax squared in the case of number 4 is like a 0x squared. It's not even there. See what I'm saying? Yeah. So anyway, all right. A circle, if you end up with a circle, then a and b, these coefficients will be the same. With an ellipse, if you multiply a times b, you're going to get a positive number. It's greater than 0. With a hyperbola, if you multiply a times b, you're going to get a negative number. Sometimes you'll get a line. That means you don't have an x squared or a y squared, because line means linear, right? Okay? All right? So this stuff isn't all that bad. You just have to be really careful with your simplifying and stuff like that. So that is parametric equations in a nutshell. And I hope you enjoyed it. And I'll chat with you later.